Let's graph some rational functions. Okay, it says to do stuff, find the asymptotes, find holes, find x-intercepts, find a whole bunch of different things. Okay, so um, what you need to do is, first of all, recognize what form these are written in. So 37 and 38, a little different from 39 and 40, in that they're written more like where they give us, they're almost written more like polynomials, where they've got this -3 at the end. And actually, both of them have -3s at the end. That is your horizontal asymptote. Horizontal. And both like that. We're going to work them at the same time. Both your horizontal asymptotes are at -3. And why is that? Because these functions, they will approach this horizontal asymptote as x gets bigger and bigger and bigger. Like if we put 4,000 in there for that x, what's 2 divided by 3,997? It's almost 0. So it's basically nothing minus 3. So we get really close to -3. And eventually this is basically 0. So all that's left is the -3. That's why it's the asymptote. It gets closer to it, but it never quite makes it. All right, and then tap into your knowledge of rational expressions. And what would the excluded value be from this denominator? It would be that x cannot be 3. So that is a vertical asymptote, where everything on either side of this is okay, but 3 is not okay. And for this one, x could not be 0. Whoa. There we go. So there's our asymptotes. Those are the only ones we've got. So let's move on to intercepts. There's a couple ways that you can figure out how to draw your the actual function, but I think finding the y or the x-intercept is really helpful. So what is true about a point on this line? It's the way we find all of our intercepts, x-intercepts. We do it by setting the y value equal to 0. And we find out what x value would make those y values be 0. So we've just got to solve this. We're going to add 3 to both sides. We get 3 equals 2 over x minus 3. I'm going to multiply both sides by x minus 3. And that will cancel that out on that side. We got 3x minus 9 equals 2. 3x equals 11. X equals 11 over 3, which is just 3.67. So 3.67 would be right there. All right, and the significance of that is that we know that this is in this upper right quadrant. The function actually looks like this. You draw it where it goes towards those dashed lines, but never crosses them. I'm doing my best there with this thing. And so we know the other one would be on the other side of that, somewhere down here. But what is the y-intercept? Well, the y-intercept happens when x equals 0. So let's find that one. 2 over 0 minus 3 minus 3. 2 over -3 minus 3. That would be -3.67. Same number, opposite side, opposite axis. So right here, -3.67. So this function is going to go like this. Could have drawn it better. There we go. So it looks something like that. Let's do this for 38 as well. So I'm going to find out what the x-intercept is. I'll add 3 to both sides again. 3 is -1 over x. That means 3x is -1. That means x is -1/3. -1/3 is where it crosses hold on. Not sure why my brain was so taken aback by that, but it's going to go through that point where x is -1/3. And then the other side would be over here. And you may think, well, Mr. Hines, what about the y-intercept? Well, this thing has a vertical asymptote at y = 0, which means it never crosses the y-axis. So there is no y-intercept. All right, let's jump down to 39 and 40. 39 and 40 require a little work on our part to try to figure out what the what this may be, or what the function may look like. So we're going to factor both the numerator and the denominator. So I need factors of 4 that add up to -5. That would be -4 and -1. Factoring this is a little more difficult. I'm going to take the negative and just put it out front. So I'm basically doing this: -3x² minus 9x plus 6. And I'm going to factor out a 3 there. So 3 times x² minus 3x plus 2. And factors of 2 that add up to -3 would be x minus 2, x minus 1. And what you'll notice here, maybe, is that the x minus 1s cancel out. So this becomes -x minus 4 over 3 x minus 2. And that's our function. That's a simplified version of the function. So what is this x minus 2? Well, that's our vertical asymptote. It would be the excluded value. It's what we cannot get to. But also, from the original, we crossed out an x minus 1. So x = 1 is a whole. And how do I know what the value of that would be? Well, if you tried to plug in 1s here and here, that would be -3 over 1 minus 2 is -1 times 3 is -3. This would be -1. So when x = 1, y would be -1, and we would have a whole right there. So it's like we would graph the function as we normally do, but when we get to x = 1, we know that the function isn't there. So we draw a little hole to show, right, paying last respects to the fact that there's an x minus 1 that canceled out. All right, so what do we do about the horizontal asymptotes? The horizontal asymptote, if you were to graph the original, it would help you to see it. So I'm not going to take your calculator away from you. You can graph that thing. But basically, we're looking at the coefficients on the highest exponent in the numerator and denominator. So this one has a 1, this one has a -3. So -1/3 is the horizontal asymptote. It's right here. We can see that our function is going to kind of go like this. It's going to be up here and down here, so they can go through that point. Let's confirm that. So we need to find the y-intercept. What's true of the function at the y-intercept? That means that its x value is 0. We can use our simplified version, or we can use the original and plug in zeros for the x's. So y equals -0 minus 4 over 3 times 0 minus 2, -4 over -6. So that's 2/3. Y equals -2/3. Like right there. And so I know my function looks like this. I'm going to get to that and just jump right over it. So there's a hole in my function. Well, there's going to be an x-intercept over there. I want to know where it is. So, sorry, not sorry. I'm going to do some work right here. I want to know what the x value is that makes the y = 0 again. So -x minus 4 over 3 times x minus 2. I'm going to multiply both sides by 3 times x minus 2. That'll get rid of the denominator. But what happens when I multiply by 0? Nothing. So 0 equals -x minus 4. I'm going to add 4 to both sides. Uh-oh. This is not. Oh, it should be +4. This should be in parentheses, which means I would have to divide that and it would still be 0, but this would be plus. Or I mean, this would not be plus, this would be plus. Sorry if that confused you. When I cross out the 3 and the x minus 2, I still had a negative out front. You could either distribute that to both or just divide it away. If I distribute it to both, I'll have negative x plus 4. That would make this minus 4. We would have negative 4 equals negative x, x equals 4. So I'm a little off on my graph here. And that's why we find it, so that we can draw a more accurate picture of what the graph should look like. Oh, perfect, perfect, perfect. All right, let's try again with number 40. This one's a little easier to factor. Greatest common factor in the numerator, 3 times x plus 4 over x plus 2. Nothing is going to cancel out, so no wholes are going to be left. But the excluded value for x would be -2. So x can't be -2 because it would make us divide by 0. And then what is the horizontal asymptote? We look again to the x to the first power is the biggest power in the numerator and denominator. So 3 over 1 is 3. We're going to find x-intercepts and y-intercepts. Let's find the y-intercept first. The way we do that is by plugging in zeros for both of the x's. When x is 0, y equals 3 times 4 over 2, which is 6. So there's our intercept right there. So this function is going to be here, but then it's also going to be down here. So there's an x-intercept somewhere in this region. I want to know what it is. So instead of plugging in 0 for x, I'm going to plug in 0 for y equals, come on, pencil, 3x plus 4 over x plus 2. Multiply both sides by x plus 2, cancels it out over here. If I multiply this side by x plus 2, it's still going to be 0. 0 equals 3x plus 4. Let's divide by 3. We get x plus 4 equals 0. Subtract 4, get x equals -4. That's right there. So this is going to look like this. And that's all there is to it. The questions I might ask you on this would be, I might give you the equation and say, what is the horizontal asymptote? You have to tell me. I'll say, what's the vertical asymptote? I might say, is there a hole? If so, where? I might have a set of graphs and ask you to pick out which graph is the correct graph. Those would be all possibilities. And they could be written in this form or in this form up here. Alrighty, that's rational equations, rational functions.